Hello everyone. Uh, it's been a long wait. Actually, yeah, there is a huge gap between my previous session. I think it was on, I do not remember the date, but I think it's been 2 weeks since we haven't connected or I haven't posted any video. Yeah, I think on almost 11 days. So it's been 11 days. So sorry for the delay in this particular video. But I have been working. There are a lot of things going on, and obviously this is a vacation season. So uh, right now the frequency, I'll try my best to uh, maintain the frequency like daily or uh, a video daily or a video like once in every 2 days. But yeah, sometimes it is more difficult for me as well to manage everything. There are a lot of things that are going on. I'm also upgrading myself like for certification exams and others. Looking for another role switching. There are a lot of things going on, so I'll try my best to connect with you guys. So here, uh, recently we have been working on. Let's just have a brief recap of our session, of our previous session. In previous session, we have discussed like what is. Let me just open that. Uh, what is the CI/CD? How do we configure a CI/CD pipeline using GitHub GitHub Actions? So there are a lot of options. In fact, my preferred, I have extensively worked on mostly Jenkins. Okay, I'll show you Jenkins as well. Why? What? Like what do we have in Jenkins and how to configure it, how to use it. It is completely open source and it doesn't require like you can develop your own. There are a lot. It is like if you want to customize it, you can customize each and every component of Jenkins. In fact, you can write if you are good at Java or it has been basically developed in Java. So if you are good at Java development, you can create your own plugin. Okay, so there are a lot of customizable option in Jenkins and so many other things. So I'll surely show you that how to configure. But right now we have what we have configured here is we have like set up a uh, GitHub CI. Okay, uh, GitHub Actions. Yeah, let me just open. Let me just open the where is 3 tier app, 3 tier web app, AWS. Okay, so this is how it is looking like. So there are a lot of CI/CD options which are available in the market. You can use any one of them. Okay, but I would I have shown you on this one like I have shown this particular one to you because you don't have to configure it. You just have to configure a runner. Okay, and here I am using this my DevOps VM as a runner. I think if we run psfnu graph. So this file is currently running. Here you can see this particular run svc.sh. Okay, run svc.sh. It is currently running. Okay, so uh, this particular file you can see it right now. Let me just open it. Okay, let it be. Okay, I think. Okay, so what is it running? It is running like convert system type kill. So what I'll do, I'll just like sudo kill hyphen 9 this process ID. I want to kill. Right now it is killed. Okay, here I'll just activate run.sh. Oh, run. Okay, this is running. Let's just see if we have our actions in our actions. I think runners 0 available. Yeah, our 100 days of DevOps. It is session already exist. Kill this one as well. Session for this runner already exists. Let me check what is the issue with this. Let me just reboot this system. It is connected. I think it should enable our runner. Right now it is idle. Okay, this particular runner is idle, so it is running, but for now what I'll do, just it will just print the logs over here, and here you can find. So my runner is currently working. Okay, I have configured my, so it is idle. right now, and everything is working as expected. So let's just go to our code. Providers.tf name subnet. So this is what we have. This is where we have left on our D27. Okay, we have discussed a brief about output.tf and brief about like provider variable. Okay, profile temp and everything. So right now I'll just show you let me just open my AWS console. Okay, in this AWS console right now we do not have any VPC which is available for so we have created a simple CI/CD pipeline that will as soon as we update the code it will provide us VPC. Oh, I have to search for VPC. Okay, so okay, so only default VPC is available in North Virginia region, which is US East one, and here in our provider we also have configured this. So region provider, I hope in uh, just revisit my previous session what we have done over there, and yeah, there is one more thing that I have done in here. So updated env, actually I want to, yeah, this is the part on 14 December. This is where we have left terraform.yml. This is what we have created. Okay, so I just want to create this is for updated env, use profile temp, uses. So I'll just create a new branch over here, which would be secret management. This is a separate branch. We'll discuss it later. Right now we are in main branch, which we want to continue, and I want to go back to my code on which was on 14th of December, on which we have recorded our day 27 video. So what I'll do, I want to show you one very important task. It makes and breaks a particular code base. Okay, so it is called resetting a branch. So suppose right now what has happened, these two branches are uh, I have developed one feature for secret management in my CI/CD pipeline for Terraform, but it is not yet developed, and I have merged it to the main branch. So in main branch, this code is not yet ready. Secret management code is not yet ready. Still, I have merged it, which caused me a trouble. Okay, my main branch is also uh, like not working well. So how can I fix this? Okay, how can I fix this? How can I revert? Oh, I think I have. How can I roll it back to our to my desired state? So desired state is this code for 14th of December when where we have node install configured. Okay, so to do that, there is a simple command that we can use, which is git reset. Okay, git reset, it is very harmful command. Harmful in the sense like there are two three tags. Okay, git reset hard, git reset mixed, git reset soft. Soft means uh, git reset soft is for like you want to, you don't want to delete the changes that you have made, but still you have to reset your reset your code to a previous version, okay, previous commit tag, okay. So that particular version you can do that, okay. And here you can see hard, soft and mixed, okay, here. So mixed is like it will uh, what it will do, like it will reset the code, okay, keep the changes but keep all the commits as well, okay, keep all the commits as well. So not all changes would be lost, only the index which is like if I'll just show you git status, okay. So git or git log, hmm? So this is git log. So right now what do you see, this is head is set to main, okay. This is this head is set to this particular commit, okay, this set of main branch, and secret management is also in the same. But what we have to do, we want to uh, we want to set this head on December 14th. This is December 17th, this in December 14th. So this particular tag we have to reset to. So in soft, what will happen, all these commits would be deleted, all these commits would be deleted, but the changes would there, unchanged unsaved changes would be there, okay. So that is called the soft reset. Then there is mixed reset. Mixed reset would only just pick this head from here and place it over here on day 14, okay, place it over here. So I'll just show you the like here I have copied this, quit git reset, git reset hyphen hyphen mixed, okay, and place over here. So here I came up on this, and if we just check, so uncommitted changes, here my like what output.tf. So here my commits are still the same, okay, here my commits are still the same. So this is the mixed branch, okay. If I show you git branch, git log, so you can find it. So only head has been reset, this is the mixed one, okay. But what if I have to like reset it to this particular git, oh, git reset hyphen hyphen, okay. So again it's set to here, okay. Similarly, if I just set it like I have reset it to mixed, now let's just reset it to soft. So here you can find, so similarly it, they both are similar, but in the sense I'll just show you. So here head has been changed to this particular one. So mixed is good, soft is good, okay. So it will help you to keep your like code as is, okay, to save your code. But suppose let me just reset it to the previous version, git reset, oh, here we are. But suppose here you have seen like I have done the reset, and all the code has been in the all the code changes are still there, but they are like uh, unsaved changes, or sorry, so unsaved changes and everything. So here you can do that. But what if we don't want to keep the changes, I don't want those changes. So what I'll do, there is one option which is called git reset hard. So hard reset is a dangerous thing, you should think twice before that, and it is done. Okay, this is the hard reset. So I haven't saved any of the changes which are available. Okay, I haven't saved any of the changes. I just have moved to a new one. Okay, uh, like yeah, all the new changes have been lost. Okay, so that's how the hard reset works. If you do the hard reset, you won't roll it back unless you have saved the comments, saved like saved the commits in another branch. So this is the reset. And there is one more dangerous thing that is discouraged to be done, which is called forced push. So I'll just do git push here. So why it is rejecting my push? Why? Why so? Because my main branch on the origin, okay, if you can see over here, this is the remote branch, okay, remote main branch. So it is ahead of my local head branch, local main branch. So that's why it is not accepting my push request. So there is one more thing that we can do, which is called force push. So it will override the head on the remote repository. So here you can see. Now origin and main, both of them have been rolled back to particular version. So this is how it works. Okay. So you should be very careful of this, and I think this should have triggered. Yes, Terraform job is running right now. Okay. So that's how you can run it. I'll just show you on the runner. So this is git reset, git update. Yeah, node installation configured. So they both are running. Here you can see, like, yeah, Node.js is running right now, and so everything is check, validate, plan, apply. So I think it would right now no resource is created over here. So it would be created in a short while. Once the Terraform plan is already going on, I think Terraform apply would also work. Okay, so this is how. So now let's just, what I can do over here is I can create a new branch. Okay, create branch. What branch it is? It would be 3-tier app network. Hmm. Check out to this particular branch. So I'm using this UI tool, but uh, you can anyway, if you are not very familiar with your command line. Okay, so first make sure you just have a good grasp of command line and everything. So that would be most preferable one. First of all, just check what just be familiar with the commands, and then you can use any of these plugins and everything. If you directly go on this plugin, you wouldn't know like what is happening behind the scene. Like I could have uh, reset the branch over here itself. Okay, here itself, here you can see, like, here, revert, rebase, merge. There are a lot of things that are currently going on. Suppose, yeah, reset to current branch, reset current branch to this commit. So I can easily click on here and everything, but I have to show you the command so that you can easily do that. And I think our code is successfully completed. Yeah, code is successfully deployed, and let's see. Yes, sandbox sandbox VPC is created. So this is for the in IAC. In DevOps, actually you just have to like there is one concept, X as a code. Okay, X as a code in DevOps. So everything that you write, where did it go? Here we have X as a code. X could be anything, infrastructure as code. Okay, infrastructure as code. Okay, then we have CI/CD, CI/CD as code. Okay, and we have config as code, config as code, security as code. So basically DevOps actually works alongside two core ideology. First is the automation, second one is the agility. Okay, and that agility is provided by like writing these kind of codes. So everything is scripted. You just have to you can just easily start where you have left. Like I have left it on 11 days ago. Okay, but here I can start it from where I have left. And as we write everything as a code, okay, so best thing is to keep it in some kind of code repository like Git and something, so that you can easily track where what you have, like what is it, infrastructure as code. So these are some of the okay. And MD, this markdown language you should be aware of, because all the readme files that you write or anything that would be written in this one. Okay, in mm, so that's how you should be writing it. So X as code is one of the concept, and Git would be your like best friend when you have something like this. Okay, so you should use Git as much as possible, write every code and everything. So that is the task that you can create over here. You should be familiar of. Okay, so let's just move ahead with what we have planned. So first of all, what we'll do today, I actually have took a huge task. Okay, to deploy a 3-tier application infrastructure for a 3-tier application. Okay, but 3-tier application should be like deployed in some kind of in chunks. First of all, let's just set up the network. Network would be, it is like setting up the stage for our application. Okay, VPC should be there. Okay, there should be the subnets available. There should be like on these resources security groups would be available. So a lot of things that then we have like first of all set the network, then set the compute, then like persistent storage. Okay, so a lot of things that we could make sure. So this is how you can deploy it. So yeah, so let's just move ahead with this. I'm just closing this preview. So as of now, we have Terraform YML uncommitted. Why is it uncommitted? hmm, terraform.yml. So it is created, it is running fine, so I'll just keep it as is for now. Let's just move ahead with this. So we have created, I'm just renaming this particular file as VPC. So what could we do over here is, it is like it is like suggested, it is recommended, like you should use separate files. Okay, separate you just split the whole configuration, whole cloud configuration into separate files like VPC, then subnet. Okay, here I'll just rename it VPC subnet.tf. So how could we configure it? So let's just see. So first of all, we have configured like in providers dot, where did it go, providers.tf, then vpc.tf, then we have variables.tf. Okay, so these three files are given over here. So we have configured everything, vpc subnet, and yeah, suppose aws vpc sandbox id. This is the vpc id, vpc cidr block. Yeah, we have kept in cidr block. Suppose I just want to use this cidr block like a variable. Okay, so I'll just create variable public subnet CIDR. Okay, public subnet CIDR. So type would be type description CIDR1. So what we are planning to create uh, two CIDR blocks, two public subnets. Two public subnet. One is for like they both have different availability zones. Okay, so here you can just configure it, or just like CIDR blocks. Mapping map for public subnets in a public subnet CIDR in different AZ. Okay, availability zone. So to create like a resilient fault tolerant application, you should be work on you should like make it redundant. Okay, so type would be type map, oh, map is fine. Then default, if what was it, if availability zone is US East 1A equal to this. Okay, and US East. Okay, this is how it should be. So default public subnet CIDR, let's validate it. Okay, so this is how it would look like, and I'll just add it over here, public subnet. Web subnet type public and VPC ID. Add it over here. So it might where public IP declaration map. Why is it showing this? Terraform validate. Mm. List type constructor require argument. Just a moment. I think I might be doing something wrong. Data type. Data type map. Okay. So variables can be defined in multiple data types. Here you can check. Okay. So what is happening? 300%. Yeah. So there are different types of variables in Terraform, which are basically there are four, which are like bool, list, numeric, and string. Okay, bool, list, number, and string. So on top of here you can see. Then there are map, set, map, and set. Okay, these are some of the data types that you should be aware of. So map over here, map or object, list, tuple. Function default, and I have created the same, right? Type map, variable, type map, and default. I think that is the correct syntax. Let me just check if it would work. Mm, Incorrect attribute value type. Map of dynamic. So no worries. I tried one thing over here, but it didn't work. So let's just see. CIDR1. CIDR1. I'm just doing it. String, and default would be My plan was to like create a simple map over here, map data type, that will directly put the default value. Uh, yeah, so I think this would be working fine. So right now, if I'll just go to, if I'll just go over here in this VPC, I don't think there is any subnet or any resource in this particular VPC available. Okay, so hmm, web subnet one. This this is ready to work. And here, if I just show you web subnet one, web subnet one is created also. Oh, okay, okay. It has been previously created. Okay, that is fine. Web subnet one is already created over here. So yeah, this configuration is valid. So what I'll do, I'll just commit it. So in main branch, I think you can directly find out why is it showing this particular, where did it go? Yeah, these are the current main.tf has been deleted. Okay, so I'll just create like VPC subnet created. No, public subnet. Publish branch. That is fine. So if I just go to my main branch here, so yeah, in main branch you can find why is it showing up. We have main.tf. Yeah, here we already have provided the subnet, so that's why it is also available over there. So we have created this, and that is fine. So now let's just see what we can do over here. So I'm just going back to my board. Here it is, and go back to pull request. So what I'll be doing here is I'll just create a pull request to test compare request. Okay, uh, web 3 web tier 3 tier app network has been created 1 minute ago. So we can just create on the pull request. This is the pull request main, and able to merge, you can find it over here. What configuration you have created, then you can just create a pull request. Okay, so with pull request, what will happen, an action would be triggered. Okay, here you can see. So just so here you can see an action has been triggered with this. Why? Because I'll just show you why it has triggered. Because in Terraform dot so there are multiple events. Okay, action and events. There are two types of jobs that two types of uh, two parts in GitHub Actions. Okay, there are events which are the triggers. So like on means on what event do you want, like a pull request has been created for which branch, main branch. If a pull request has been created for main branch, then run this particular script. Okay, this particular script has been run, and if the job is successful, okay, if this particular, so we can like here what will it do? It will just create everything uh, right now in merge, because we have like Terraform apply also in the same in this particular file. Apply also is available in this same file. So that's why it will just create. But however, in the PR state, okay, in the PR state, what happens? We don't like create this apply file. We don't create apply stage of Terraform. Okay, so that the if the plan would be successful, then the whole job would be succeeded. So that's how it is right now. But right now we just have started it, so we are just keeping it as is. So all the checks are almost completed and we are ready. Yeah, here everything is completed. So yeah, we have merge pull request. We are ready to go. Confirm merge and we are good to go. So that's how we can configure like any anything over here. Okay. So if we go to subnet, web subnet 1 is available. Now suppose I have to create like Terraform AWS Terraform provider AWS, okay, subnet. So this is AWS subnet. I want it to be in a particular availability zone. Let's see if any option is available or not. So here you can find, yeah, availability zone. Okay, like I want it in a particular availability zone. So I just copy this and go back to where was it? So I'm going to this 3-tier web app. Okay, 3-tier web app. I'll creating I'll be creating in this one. So 3-tier web app. In 3-tier web app we have VPC. Yeah, and this is subnet one. What if I want like I'll just add it over here. Subnet availability zone. If oh no, US East 1A. US East 1A. Okay. So they you have seen like I have saved it and it has formatted it automatically. So that is because of the plugin. Okay. If you want to do it manually, there is one command for that as well, which is called uh, Terraform format. Okay, Terraform format. So it will automatically validate format. Terraform, yeah, FMT, this Terraform FMT, this to reformat in a standard Terraform FMT. So right now everything is in particular format, so that is fine. We have created it like this is for one. And suppose I have to create another, this is web 1, web 1 resource, okay, web subnet 1, and I have to create another resource for myself which is called web 2, web 2 public subnet CIDR2, VPC ID would be this would be this, and okay, subnet 2. Yeah, so if you can see over here, we have to do it again. Okay, we have did it again. Just did this. This is the subnet. You can easily manipulate the code over here, and here you are good to go. Let's just commit it. Okay, here you can see the modifications that we have made. Oh, no, 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 no. So here you can see, yeah, all everything is working fine. No need to worry on this one. Everything is running. So these are the changes that we have created. Okay. So public subnet, edit, sync changes. Let me just create the PR again, but this time I won't be merging this PR. Okay, so that right now we didn't have deleted this branch. Yeah, maybe subnet is here. Let's check if let, let it be. We can create a new PR over here. 3-tier app. Okay, so here you can find everything. Create and create pull request. So I think actions would start. Yeah. So yeah, public subnet to edit. So here, if you can see, so in subnets, so here you can see, so it has been created, but there is one little glitch over here. What glitch do we have? You can easily identify it, like multiple resource with the same name is created. Okay, this this subnet. Okay. this subnet is created. Uh, but I don't think like available. Why CIDR overlapping? Why is the CIDR is overlapping? Like VPC ID I want for name type VPC to be sandbox. Okay, multiple VPCs has been created. So that was the reason over here. So why is multiple VPC created? Because we haven't set up any state management file over here. Okay, so I'll just show you where are the state files are being stored. So let me just open another terminal. Control R SSH re okay cd actions. So right now we are not cd work. Hmm? Here. So here you cannot find any tf state file. So that's why it is considering like everything should be created from the Terraform tf state. This is the tf state file. Okay. If I just do get Terraform tf state, so you can find like all the resources that have been created. So there are currently 3 resources being created, which are this is the AWS subnet web 1 registry. Yeah, this is the subnet ID ARN, and yeah, this is the VPC. Okay, this is the current VPC ID of that particular subnet. So here is also the same VPC ID mentioned. Here is also the same VPC ID here. So this is the current VPC ID. This is the VPC ID. So in this VPC ID we have 2 subnets which are given, but there are multiple VPCs which are also being created. So that is due to the lack of like state management, TF state management. So since the TF state it is creating a new TF state every time. Okay, it is creating a new TF state every time. So that's why it is creating multiple VPCs on that. If we make any particular change, so here if I just show you this web subnet, so here you can see US East, it is using AZ6. Why? Because I have created Z6, AZ5, AZ3. US East 1 AZ. US East 1A. Regions and zones. Okay, I think US East 1A, availability zone ID. Okay, so these are the availability zone IDs. Okay, so they have like added another attribute to it, so that is fine. So US East 1, AZ 1, 1, 2, 3, 4, 5, 6. Okay, so let me just update it, but it will again recreate a new. Was that I think availability zone ID, yeah, availability zone ID that we have to provide. Availability zone ID, yeah. Okay, I think this should fix our issue. Yeah, so it is updating right now. Data availability zone. Okay, so this is currently running. Yeah, plan apply, and 3 resources are being added. So here you can see every time it is uh, adding new resource. It does not so what it is doing in work, it is creating a temporary folder where this is the temporary folder, and it is running the plan. So every time it is creating a new plan and executing it. That's why it is not fetching the fetching it from the tfstate file. That is also we can configure it. Okay, I think it is showing like already created. Oh, maximum number of VPs has been reached. Let me just check if there is anything that we can do over here. In time there is nothing available. I think we need to delete those manually. state management. Yeah, we haven't configured the state management over here. Terraform apply. There is one thing that we could do over here is Terraform state management. Then we have like indentation is correct. Yeah, name, upload, save. Actions. So these are if we use like uses, okay, upload artifact. So these are the actions that you can take, predefined actions we have. You can anytime find it like github.com/actions. Okay, here you can find all the predefined actions that are available. Like checkout is basic example. Then we have okay, so here upload, yeah, upload artifact, this particular. So upload artifact can use for like Terraform file, and right now it is uploading. We have similarly we have the download path as well. Okay, download artifact path. So Terraform URL, Terraform ID, Terraform digest. So we are like for saving the tf state file, we are creating this, and after that we'll just create another okay. So uh, we have this Terraform upload part here, and we have like one more thing, upload artifact, and similarly we have the download artifact, yeah, download artifact. Okay, so download artifact is like it will, as of now what we'll do, we'll just save that file, save the tf state file in the local state. Okay, local state would be, I think it is failed. So with, okay, with name would be terraform dot tf state file, and then we have what would be the path would be let's just say same path, this file, and here we have used the terraform. Okay, so this is the save the terraform file. Now we have to use it like self-hosted checkout. After checkout, we have set up Terraform Node.js version 3, Terraform init. Before Terraform init, I'm just adding. Okay, so we'll be using name download Terraform tfstate file. Okay, then we have uses. What would be the download? Okay, what version is currently available? v4, right? This particular uses. v4 with name. Name is Terraform tfstate. Okay. And path. Let's see if it would work or not. So first of all, let's just delete, because it would not allow us to create any further resource on this VPC. So first of all, let me just delete all these subnets. These subnets are okay. Everything is deleted. Okay, so all those created subnets have been deleted. Now we'll just go to VPCs. How many VPCs are there right now? This. So 6 subnets are available right now, only default, and these are the sandbox. 4 VPCs. Let's just delete. Why couldn't we delete it? Do we have to delete one by one? So that's how we have to manage it. So all the VPCs are cleaned up. We can actually do one thing over here. I think this might fail, and there is flaw in this logic, in this particular logic. So what is the flaw? It is like, what if this tfstate file is not available on this location? Then this stage might fail. So first of all, let's try this if it would work or not. Okay, I have added the logic over here. Okay, and I'm also just experimenting with the available data. So I know the basic syntax, but yeah, it is mostly about the experimentation. So state, tf state management, tf state management, edit. Let's just see if it would work or not. Okay. So now it will create all the resources at once. Okay. We have deleted everything, and after this, it would like just create one has been failed. That is fine. Two errors. Okay, now what is with that? Terraform init format check as it is for the previous. Download tf state file. So I knew this could happen. Downloading the single artifact, unable to download. Expired. What is the location of repository demos flow? Var temp single artifact. What I'll do, there is one thing we can anyway add a if else condition over here. So let me just check. So here actually one tag that is available, that we can at least check if the tf state file is getting. Right now there is no tf state file, that's why it will for sure give us an error. Okay, check out code, install, download tf state file. Okay, there is continue on error. Right now it is false. I'll just make this. Oh, okay. Let's just see. Mm, 19, number 19. I think it would work now. And there is one more step that we can create over here. So like it is like a conditional statement. So once let it work. Okay, so right now though no file is available, so we have moved on. Yeah. So yeah, this is currently updated. Okay. mm, 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 mm. Save tf state file. So here you might find a tf state file. tf state file is successfully uploaded. Let's see where it is uploaded right now. Oh yeah, ls 3-tier web app ls hyphen al 3-tier, and here we go. So this particular tfstate file is updated. So I think this is the tfstate file. Date. So it is showing me like, yeah. So in this particular, it is showing the UTC time. Okay. So according to UTC time, this is the latest version of the tfstate file. Okay, that is fine. Now what we'll do, we'll add another resources. Okay, so we have like our VPC subnet, everything is up to date. Okay, and here is like, where did it go? VPC and subnet both are created, and let's just check on our AWS cloud if everything is in place or not. So yeah, sandbox is created. This is the VPC ID, and I think subnet. Where are the subnets? Okay, one hour ago. Yeah, web 1, web 2. But now, if you might have noticed one thing, so this is VPC and subnet we have created over here. Okay, we have created VPC and subnet over here. So we have to like, this is VPC, where is subnet part? Yeah, this is a web subnet 1, web subnet 2. These are the subnets that we have to create. But right now it is for public. But what if we have to create 6 more subnets? Okay, we have to create private subnet, we have to create database subnet. Okay, there are a lot of things that we have to create. So how would we do that? It is like creating everything again and again. That would be very much difficult for us, right? So how would we do it? Okay, let me just go to state here, Terraform, destroy. So how would we create a subnet? So there is one thing that is called like Terraform modules. Okay, Terraform AWS modules. Hmm. So here you go. Oh, this one. So here modules are basically like pre-configured uh, pre-configured set of like set of state. Here if you want to like create a subnet, okay, IAM, EKS, security group, lambda. So I'll just go for a EC2, VPC. Okay, in VPC there are how many input it would take, how many output it would give. Okay, what are the different dependencies? So dependency is HashiCorp AWS. It requires 5.46. Okay, this version greater than or equal to this version. So let's just check in our providers.tf. We already have been using 5.51. So it is all good for us. Okay. So let's just go to, and resources, how many resources it would create. So CloudWatch, cloud, like these are the list of resources that it would create. Okay, using this particular, this is this single module. And if we go to here, so it only creates one resource, which is the subnet. Okay, which is the subnet only. So what this module would do, I know it might be difficult for some of you guys, some of it is taking so much uh, ish, it is taking like sorry, so much it is advanced concept and everything, but let's just see. When you have to make it work, you just have to move ahead with all this. Okay, you have to go forward with all this. Okay, so that's why resource AWS EIP net count 3 to achieve this allocate usage. Enable net gateway true, enable VPN gateway true, tag, then net gateway scenario, enable net gateway true, single net gateway false. So if single net gateway is false, then one net gateway per subnet it will create. Okay, single net gateway true, it will create like one net gateway in one of the public subnet. So right now, what is the scenario? I'm just explaining you. Okay, let's go back to our this particular. First of all, let me explain you the networking basics. Okay, AWS networking part. So what do we have, or any other kind of like we have discussed net. Okay, we have discussed uh, net gateway. Okay, day 28. Hmm. We have discussed net gateway. So what is actually happening? I'm just putting it on internet. This is internet. Okay, you have like internet available in your net gateway. Okay, in any other cloud. Okay, that is fine. Suppose here I have AWS general resource, AWS arrow, AWS groups. Okay, we have okay, so this is my AWS cloud. This particular this particular resource. This is my AWS cloud. Okay, everything we have, all the resources which are available on AWS is on this. Then after this we have yeah, we have a region. Okay, this is the region. This is the region, and in that region we have our availability zones. So these two are the availability zones. Okay, so here region would be US East 1. Hmm. This is the region we have, US East 1, and availability zone be US East 1 AZ 1. Okay, I'm using the code AZ ID, and here AZ2. So these are the subnets. Okay, and this is current strategy. So before that, I'll just explain you one thing. Let's just move. Let's just copy this AWS. Hmm. So this is region and availability zone setup. But inside that, what do we have? Okay, suppose there is only one region and one VPC. This is availability zone. This is, yeah. So this is the VPC. Okay, suppose in any particular region this VPC is standing. Okay, VPC is static to VPC is a regional resource, we can say. If a VPC is available in US East 1, it can only be used in US East 1. Some of the resources are AZ specific, like subnets. Some of the, like here you can see, I'll just show you. If you go to the AWS region, so this particular subnet, it is in the US East 1 AZ2. This is the availability zone ID. However, if we just go to this particular error, loading, what error? Oh, oh, yeah, we have destroyed just now. Okay, so that is fine. So here you can find everything. So VPC is shared in a particular region. In that we have like two availability zones. Okay, in that availability zone we have created, just for now, consider it like VPC, and this is public subnet. Okay, how network works, first of all let's just talk about that. Okay, this is the public subnet, this is the, yeah, this is the public subnet. And there is one private subnet available. This is private subnet. Okay, let's just say public subnet is the internet service provider that we are currently using, and private subnet is the home network that we have. So any resource that is available in public subnet, network, networking and content delivery, this API gateway, cloud delivery. This is the internet gateway, it sits between here. Okay, this is the internet gateway in public private cloud. It is so this particular internet gateway, it has an elastic IP. Okay, EIP, elastic IP address attached to it. Okay, this internet gateway has an elastic IP attached to elastic public IP. Okay, public IP attached to this particular resource. Hmm. So this is, and this is connected to the internet. Okay, this particular internet gateway is connected to the internet. And then we have route tables. This route table, so route table is connected like it it is routing all the traffic to this particular elastic IP. Okay, basically to this internet gateway, because elastic IP is anyway connected to this. So any machine, any particular machine, okay, whether it be EC2, let's say EC2, okay, any particular EC2 instance which is hosted in this public subnet can directly, through this route table, can directly reach out to the internet. Okay, can directly reach out to the internet. Here you can find it. Okay, can directly reach out to the internet over here. But any EC2 instance which is available to which is available in the private subnet cannot directly reach out to this internet. So how would it work? So there is net gateway. Net gateway comes into picture. So what does net gateway do? Net gateway basically sits in here, okay, in this particular public subnet, okay, and we have a route table which is sitting in here. Route table is connected to all traffic to this, and here it would go to this, and AC2 is connected to the private route table. This is public route table, and this is private route table. Okay, public and private route table. So that's how the resources which is sitting. And one more thing, here anyone can this is a two-way communication. Okay, this particular communication is two-way communication. Okay, anyone on the internet can reach out to this particular any EC2 instance can reach out to internet directly. Okay, and anyone on internet, if the ports are open in the security group of this particular EC2 instance, can reach out to this particular EC2 instance. Okay, but in net gateway traffic is only one way. Okay, one way means only egress traffic is allowed. Okay, in net gateway ingress traffic is not allowed. So that's how it will work. So suppose we have created this, we have two public subnets. Let just copy this. Okay, we have two public subnets available. Hmm. And in that we can easily create like these resources. Either we can create like public subnet. Either we can either we can keep only one net gateway, or we can create two net gateways. Okay, so similarly, where did it go? This is and we have our internet gateway available with us. This internet gateway is allocated to the VPC, directly to the VPC, and then we have NAT gateway, and we have public route table. Here we have public route tables, and here we have private route tables. Okay, so this is how this is the network setup that we need to make sure of. So, and similarly, for if we add some more layer, like in tier 3 there would be database layer, so database subnets would also be have their own route tables for that, but I think they do not require the net gateway because they are not going to reach to the internet. Okay, so that's how the network. So these are all the different variations that these are all the resources that we have to create, but to create it like copy and paste, okay, uh, to write the code again and again, it would not be very helpful for us. So what we can do, we can use this module. Okay, this module can create up to uh, can create like 80 resources. Okay, so for we already have destroyed it. So what we can do, we can, this is the AWS sandbox. I'll just copy this. Okay, VPC name sandbox. Okay, this is the subnet, and we want like US East 1A 1B. Public subnets, private subnets. Let's just keep it like that. And enable net gateway to single net gateway false. VPN gateway, I'm just removing this false. VPN, I do not want any VPN gateway as of now. Okay, tags environment Terraform true. uh, so any resource which is created using this Terraform should have this tag, so that anyone can identify it and keep it as is. Okay. This is how I think this is all, or private subnet. There is one more subnet that we might need to add, but we can create, we can keep it like that. So yeah, I think we are all good as of now. NAT gateway scenarios, one NAT gateway per subnet default, it is default. Yeah, database subnet. I want this one as well. Mm. Database subnets. Let's create 201, 202. This is the database subnets. Elastic cache subnet, private red shift. So intra subnet, that is fine. The 5 net gateway can be created. Okay, okay, one net gateway per subnet default. Single net gateway. One net gateway per availability zone. Net gateway would anyway be in public subnet. Conditional. Create VPC false. I'll explain this locals as well. Locals are like temporary variables in any coding language. So example, complete VPC, complete VPC dual step. I think we are, at least for now, we are good to go. Here it will create a dev environment and let's just commit. 3 tier VPC subnet net created. Okay, so I am just committing this, not syncing right now. I'll just show you what is currently existing over here. So we do not have, yeah, we do not have any VPC. Route tables are only, these are the route tables which are available for each availability zones. Okay, and these are the subnets. I think I should refresh this. Yeah, these are the subnets. Okay, for each availability zone you can find it, like here you can find, okay, 15623. Okay, so these are the availability zones, availability zone ID, availability zone here. So US East 1E. Okay, so here I think route tables would also not be available. So yeah, route table, no custom route table. Internet gateway only. Okay, internet gateway is also not available right now in this particular region. Egress only internet gateway, that is actually not available. Net gateway not available. Elastic IP, elastic IP, I think for elastic IP right now is not created, but yeah. So let's just sync it. I don't know, I think it might work or not. Let me just check. Terraform validate module VPC. Oh, okay, but yeah, we already have our init state, init stage available. So Terraform init, let's run it over, and let's just have a look on our actions. Workflow files are created. Okay, download Terraform file. So Terraform, since we have used the previous Terraform file, it has, okay, unable to find the artifact. No worries, we already have that continue path available. So we need to fix it. There is one way. One way is like, the way is like, we can create an S3 bucket, upload the Terraform file on that, tfstate file on that, and from there we can fetch it. So we can easily use AWS S3 CP command. Terraform initialize successfully, format check, complete, validate. Validate should also be complete. Yeah, validate also successful. Plan and apply. So modules are like very easy to use, for easy to use content. Okay, so 28 28 different modules are being connected over here. Okay, you can create your own module as well, but these are some of the publicly available modules. And let's just go back to our yeah, AWS console. Here you might find, like, yeah, to elastic IP. Okay, so elastic IP are for internet gateway and net gateway. So this internet gateway, sandbox internet gateway is created. Okay. And net gateway is also created, and those two elastic IPs are allocated to this. Elastic IPs allocation ID. Terraform name sandbox US is one environment dev. Okay. Your VPC is sandbox VPC is created. Subnet, yeah, three subnet. No, so this US East 1A, US East 1. You can in fact just say sandbox. Contains name contains sandbox. Oh, sandbox. I have edited it as sandbox. Okay, no worries. So these six subnets have been created. Okay, and similarly we have the route tables also. So here you can find the availability zones. Okay, these are the availability zones in which they are available. And go to route table. So route table are like sandbox public, sandbox default, sandbox private, private US East one. So let's just go for the public route table. What do we have? So all traffic from this is targeted to internet gateway. Okay, all traffic. Uh, so destination would be this all traffic. Okay, subnet association. So these two are the subnets, and let's just go. What do we have in default? We do not have any. Yeah, default we have only one route. So internet, if any resource is available in this particular is pointed toward this default route table, so it does not have access to the internet. Okay, for this sandbox public it has access to the internet because target is added. Okay, and similarly for private we have all traffic to this particular net gateway. Okay, and private A is all traffic to this particular net gateway. So everything is created in just one click. Okay, so that's how you can leverage the use of modules. And I think for database, database where did it go? Database route tables are not all 10 of the route tables are showing up. To subnet, to subnet, public. These are, yeah, DB. Okay, okay, DB subnets are allocated in here. DB US East B, and here also 1 DB. Okay, that is fine. So DB subnets have also the access to the net gateway. That is also fine. So that's how you can leverage modules and everything. And yeah, so tomorrow we'll just check with the S3 bucket, and it is a very simple task to create a create a networking setup with the help of this VPC module. So try it yourself and you can directly create, and always like go with try something out over here, and dig deeper for more details. What is this doing? What So basically utilize your 12 months free subscription, 12-month free tier of AWS by using each and every service. Use any tag or everything. You can anyway try it out. So yeah, these are the resources that CloudWatch log group. So if you want, like, you can create log groups over here. Okay. DB subnet. Okay. DB subnet group, then AWS default network, ACL. So there are a lot of things that are being created. AWS region current partition. So these are the data source. These are VPN gateway route. We don't need VPN, so we have not. We might not have created that. APC this. So intra subnet outpost private public redshift elastic cache database. So for main services they have already have provided. So yeah, you can try it out and have a look. That's all for today. So thank you all. Have a nice day. Merry Christmas, and there are a lot of things. Okay, so it is Merry Christmas for Christians, and we have like Shahidi Divas, Shahidi Week for the to remembering the sacrifice of Guru Gobind Singh's four Sahibzades, Char Sahibzade we say. So Baba Ajit Singh, Baba Jujhar Singh, Baba Zorawar Singh, and uh, what was the Jujhar, and there is one more. I actually Char Sahibzade. How can I forget that? Jujhar, Zorawar, Baba Ajit Singh, Baba Jujhar Singh, Zorawar Singh, and Fateh Singh. Yeah. So these are the 10th Guru, Guru Gobind Singh, has sacrificed his sons for the welfare of the society and the nation. So just remember that. Okay. To all my Indian friends and everything. And so, yeah, this is all for today. Have a nice day. See you. See you in next session. I wouldn't say tomorrow, but yeah, see you in next day, next session.